Good afternoon, ladies and gentlemen. Welcome to our third and final day with the 2023 Regenerative Planet Summit. I'm happy to be speaking with Chris Hunter, one of our board members, in regards to his invention with bioreacting, air filtration, and biofuel generation. Chris, the floor is yours.
Hi, my name is Chris Hunter. I'm a career inventor. I spent quite a number of years living off-grid north of Fairbanks, Alaska, experimenting with different technologies to make life really feasible. And then I got involved with ARC, the Alliance for Reason and Knowledge. They had a project in mind for doing a vertical farm. And one of the problems you have in Fairbanks, Alaska, obviously in the winter, is the cold, and a secondary problem being that of air pollution. So on the main screen here, you'll see a three-dimensional CAD model of the Bio-Reactor air filter, and it utilizes algae, water, air, and pollution to scrub the air of the particulate contaminants, and by running the air through the water that has the algae in there and an LED light array, the algae feed upon the pollution. And by doing so, not only does it scrub the air, but the algae now produces basically a biodiesel oil that comes out the other end. And so this slide, the background would show them because it's actually a photo of the air pollution in Fairbanks. This air pollution is so thick that it consistently tops the charts for the worst air pollution anywhere in the country, if not the continent, every year. And it's only getting worse with the rapid swings in temperature in the winter. But back to ARC and the vertical farm. So I designed this as a means to pull in the pollution to provide not just a heat exchange for the building. So you would warm up the incoming air and you'd cool down the outgoing air. But you would also be able to take the pollution and make fuel that could run a generator that would be ideally situated in the basement. That could power and heat the building. So the vertical farm wouldn't just be growing vegetables. It would also be scrubbing the air and removing the pollution from it. So this picture shows the diagram of how it assembles. On the left, you'll see the main reactor housing. In the middle is the LED array strip. To the right of that is the end plate gasket, the air tube O-ring seal, and then the end plate and the attaching bolts. So to the very left, you'll see this T-fitting coming off of the bluish purple housing. That's the water outlet. And on the opposite end, on the end plate, is another T-fitting, and that's where the water comes in. Water would be maintained at that level. The air input comes in from the pipe that comes down vertically from the end plate and then rolls in through the bottom of the main reactor housing. And it would then bubble up through the water and the algae. And those 5 ports that are seen above the arrows saying, this side up, is where the now scrubbed air come out. So on average, it's estimated that each bioreactor would replace the filtration of 125 naturally purifying trees. There's a huge loss of biodiversity. Every time you build a house, every time you cut down the trees to build a road, to build a subdivision, every time you clear the easements for power lines, you lose biodiversity. You lose the plant life that otherwise filters the air. So the direct usage benefits, you get an increased thermal efficiency of the heat exchange from the incoming and outgoing air. So when you bring in the air into a building, typically the air comes in much cooler than the air goes out, unless you live someplace where it's sunny and you have a lot of air conditioning. But talking about Fairbanks here, warming up the air that's coming in reduces the amount of heat that you have to use to keep the building warm. You get the direct filtering of the air coming in as well as what's exiting the building. So a lot of people don't think about this, but everything from pet dander, office dust, be it the fine particulates from papers, lint, you name it. As air moves and there are people living and working, there's a lot of pollution that we don't see, we're not directly aware of, because it's not that big of a problem, except for when it is. And that problem is what we need to start addressing here and now. So this is one solution to this. The other problem is most air filters for a house or building use a paper filter, a very large element. It's usually, 2 or 3 feet by about a foot and roughly 3/4 inch to an inch thick. Those filters are made of paper. They have metal, and when they're full or plugged, the typical answer to that is to remove it and put it in the garbage. So all of that pollution is just put away. There is no away. That just means out of sight, out of mind. So by removing and reducing the usage of paper filters and converting that pollution into a viable, regenerative, renewable fuel, a green fuel, it increases the local economy by allowing a local fuel distributor or a vendor to go around and collect this. So if the building is the heat comes from, say, electric, many places are, even if it uses a heat pump, this can still be used. And instead of an auto pay, auto fill program like what Crowley and other fuel distributors in Fairbanks use, where they know how much fuel you're using and they will automatically bill you, send out a truck to refill your heating oil. This could be done in the reverse. You would have either a smaller fleet of trucks and pumps, or a once a month thing where the biofuel would be collected and brought to a central facility, either processed or then sold from that facility. This increases the availability of biofuels. It increases the local economy and brings value to individual houses, businesses, and basically any structure that's being kept warm and has any kind of HVAC system. So the manufacturing of it, I had talked with Kevin Tubbs of Turnleaf Bioplastics. He has a injection molding facility. He can take any kind of plastic, whether it be recycled plastic, it can be algae, it can be biofuel, it can be waste veggie oil, and he can turn it into injectable plastic that would be injection molded. A lot of people aren't aware of, and some are, that common items in your house, be it the handles to your scissors, Legos, the case to your phone, even the laptop you're using, or even the mouse, those are all made using injection molded plastics. It takes on average 60 seconds to manufacture something with injection molding. The metal casting comes in 2 parts. They bring them together, they bolt them together, then they heat up the mold. They inject the plastic, they pull it immediately out of the heat, cool it down, pull it apart, and the piece falls out. 60 seconds. So it is estimated that the retail price after taxes, after shipping, and after markup, because there's a cost involved, and then obviously a profit margin for those who are selling, say, for example, if you're going to buy these at Home Depot or Lowe's, there's a markup. It would be just under $50 per unit, which makes it interesting because if you have these set up in a building, let's say a commercial building, whether it be a bank or an office building, or even a welding shop or an automotive shop, it would make that office or business eligible for an initial carbon credit and a recurring carbon tax credit. So the business itself selling these units to be used would get a carbon credit. The consumer, the end user, would be receiving a carbon credit. And then as a commercial entity, you would have a recurring carbon tax credit, which brings another aspect to mind. If these were arrayed in a building, much like how people set up Bitcoin mining, and it's pulling the atmospheric pollution and converting it to biodiesel, and they're selling that biodiesel. There is another program by the EPA. If you manufacture your own fuel, there is a huge tax rebate because you're not purchasing the fuel at the pump. You're not purchasing the road tax. They actually give you such a huge tax rebate for every gallon of fuel that you manufacture on your own. This could potentially be eligible for that, which would obviously increase the economic viability. The product valuation of this, as we increase the standards of housing, construction, renovation. For example, the house that I'm in right now is just over 100 years old and is rumored to be Al Capone's summer home here in Baldwin, Missouri at Castlewood Park. And it was recently renovated. I guess the property, according to the tax maps, was purchased for $1.2 million, 1,600 square foot house. I imagine when they pulled the walls apart, they found substandard insulation. They obviously found that the windows were substandard by today's practices, and they put windows on the outsides of the windows to preserve the historical value of the house. But the heating and cooling system were updated. The insulation was updated. There was better doors, better siding, vapor barriers put in. These are the kinds of things that increase the value of a building, increase the value of a house, whether it's for commercial, renovate and sell, commercial, renovate and lease as a rental, or even if you're just going to live in it for a couple of years and then sell it when the market comes back. This is a product that when you put it into a building, immediately increases the value. There's an immediate return on investment. It's not something that you have to sit around and wait for. There are technologies that in the past, such as solar photovoltaic, you would purchase it and you'd be sitting on it for 10 to 20 years before you got a return on investment. So that's part of the product valuation. The other part is the annual gross national sales during a housing boom are estimated conservatively at about $50 million per year. And on the, I say when there's a recession in the housing or economic recession, when times are lean, that it can be as little as $1 million per year nationally. And that's for renovations, new construction, etc. Now back to Fairbanks, the initial rollout plan with ARC was to be not just for public display, but also in partnership with ARC. So people could see these being used. They could see the exploded view. We would probably have one that was made out of clear acrylic, so you could actually see it in action. You could see the algae in motion. You could see the LED light. You see the bubbles. You see the flow of it. It would be a very simple, easy to set up display that would be fully functioning. Now, Fairbanks is a hotbed for innovation, technology, research and development. The likes of Harley-Davidson, Boeing, Ford, Nissan, Chevrolet, Hewlett-Packard, Carrier, all these manufacturers, they come to Fairbanks and they test their equipment. It's easy to say, oh, this works in California, but that doesn't mean it's going to work in the Arctic. But we do know if it works in the Arctic, it's also very likely that it'll work in the warm area, say California, Arizona, Texas, New Mexico. So they do their product testing in Fairbanks, which is great because Fairbanks being the proving grounds puts the extreme environment testing to the absolute limits. So in January, on the 10th of 2023, the EPA ruled against the Fairbanks North Star Borough's EPA air pollution mitigation plan. It wasn't good enough. And Mayor Bryce Ward was found to say solving the air quality issues requires innovative and unique solutions, not cut and paste options from the lower 48. Now, I'm from Alaska. I've lived 40 years in Alaska, and right now I'm down in Missouri, in the St. Louis area. I know what it's like. This isn't a cut and paste option. I will be coming home to Alaska eventually. So why Fairbanks? Again, it provides the ideal testing. This was the town I chose to model from in working with ART. There are 13,233 homes in the Fairbanks area across 20,877 acres, with an average of 137 acres or 137 trees per acre. And the frost-free season, which means there's leaves on the trees and things are growing and they're alive, it's only 116 days long. It's a very, very small window of time. But if each 5-pack filter, which was shown on the first slide, did the air purification of 125 trees, when it's applied to all 13,233 homes, and not just filtering for the 116 days, but filtering all year round, it would equal 97.2% replacement of human-induced loss of biodiversity. This is back where the roads, the houses, the parking lots, power easements, you name it. Everything that was required for human expansion, construction, economic growth, and existence as a society, a culture, a city. This would replace 97.2% of what was lost. It's a huge number. When you look at how much biodiversity is lost in larger cities, it makes it possible to legitimately see how this is scalable, not just to Fairbanks, but to other cities, and not just in Alaska, but everywhere on this earth. So this slide shows some different angled views. So you can see all the different sides of it. And back to the air pollution picture, a viable solution to air pollution. We can generate a renewable green energy fuel source. We can increase key economic valuations in several sectors. And yes, it truly is that simple.
All right, thank you very much, Chris, for that insightful discussion. So tell me, what are the moving parts in there? What can break in this? What can go wrong?
Oh, well, let me bring up a 3-dimensional model and we will go through the guts of it. We can bring this up. There we go. All right. So this was the program that was used to make it. And let me get rid of the cursor. There we go. So this is the air tube. As you see, it's hollow. Mm-hmm. And there's outlined all these. Let's see if we can highlight it again. All these all these holes, and then there's these vertical air turbulence tubes. And I'm going to give it a little bit of a rotate, and I'm going to zoom in. So the air tubes here, the top of the air tube is just below the water line, which I will see if I can get it to, I'll have to go to the other model for that. Let me pull that up here. All right. And we will center this on the screen. All right. So right here is the outflow of the water. This line here is the water line. Now zoom out. The air tubes here, you have the turbulence tubes, and then you have the air jets here. The air comes in through here on the bottom, bubbles up through the water, and the water passes through. Now on this green patch, that's where the LED display, or the LED array, sorry, not display, sits to shine light down onto the algae. Now the upper part here, as the water is churning and bubbling, obviously we know it likes to splash. So it would hit this triangle, it would hit this triangle, and of course this here, that triangle, that upside down V, and the water would then flow back down, and the air would then come out through these ports that are on the top. There's 5 on each side. So it's pretty much a free flow device. The water then exits through this T-fitting here. One question that's been asked is, how much power does this consume? LED lights, as we know, are quite efficient. And let's go back to the other, there we go, are quite efficient. So negligible wattage there. Most people use outside lights that consume far more wattage than this would. Most HVAC systems or central heating systems have what's called a squirrel cage fan. That squirrel cage fan, when either pulling the air through this by vacuum to pull it through, or by pushing it through the air tube here, which the air would come through, down, and in, the amount of pressure required is so low that you could blow through it with just your lungs. So the amount of airflow restriction is so minimal that you would probably only see a 1% increase, if that, on your air filtration. You know, by adding this, the squirrel cage fan would use probably 1% more wattage to do so. So that's the working parts. There's nothing in here that would wear out. And this is the LED array right here. I'm going to go to the 5-pack so you can see this. There we go. So on the 5-pack, we have the air intake. You have the 5 ports coming in through the air inlet. Let me get this to rotate. You have the water pipes are all teed together, coming in, coming out. The outflow of the water would go to a water reservoir that has, obviously, there would be an addition of water every so often. Oil floats on water. So above the water line and the reservoir would be a pipe fitting coming off the side. In fact, I have an image of that. Let me pull that up. Be patient with me here. I have the, okay, I gotta move that so I can see it. There it is, separator tank. So you can see this. So this is a cutaway fuel. So we have our cutaway view. So we have the water inlet, water outlet, and then the biofuel outlet here. And I'm going to rotate the view so that, there we go. We have the inlet here, the outlet here, so the water would be circulating through this. And then above the water line, we have the outlet that would come out of here and would feed the biodiesel into a separate holding tank. And that's how simple it is to separate the water from the biodiesel that's produced. So obviously a small circulator pump, which consumes 13 watts, those are called taco pumps. It can handle the algae biodiesel water slurry. And you know, obviously every now and then you would have to be adding a little bit more water. So on the top of the tank, obviously a big inlet. Check fill for, some people prefer to add sugar to make algae work a little faster. If they want more, they can add sugar, they don't have to. So that's the holding tank.
So working in Fairbanks, how do you keep the water from freezing?
Oh, this would be mounted inside your building where the temperature would be room temperature. You wouldn't have this put outside where it would freeze. This would be inside.
So like in your boiler room, and then piping the air, fluted air in from the outside through a heat exchanger.
Well, this would actually be the heat exchanger. So by bringing, let me pull up the other, yeah, oh, I think that was the other view. Hold on, there it is. So you'd have one of these coming in and going out. So as the air came in from the outside, it would come in through this, bubble through the water, the air would exit through there. So it would be filtering the air, but it would be cooling it'd be cooling the water, but you'd have one of these exiting the house. So you'd have the air coming in from the house and exiting from here out, and the heat loss that would otherwise be going straight outdoors would be captured from the water from the inside filter to the outside filter, basically labeled inside outside, as that's the source of where the air is coming from. And that water would be the heat exchange medium between and with that, that would provide the heat exchange medium to warm up the incoming air and cool down the outgoing air.
Okay. So you have multiple units here. Is there any value in scaling up the size of the units to like 300 gallons? Or do you think it would be better to keep it at this side and continue to add multiple units incrementally?
I would keep it at this for a standard 1,600 square foot house. I did the airflow and water flow and particulate carbon capture, hydrocarbon capture. And if I found that for every 400 square foot, you'd have one of those bioreactor units. So a 5-pack would be more than sufficient for a 1,600 square foot house with some reserve capacity. As far as the expansion to array it, if you had, say, a house in the city versus one that's, say, further out from the city, it would be advantageous to increase the number of these to increase the amount of carbon capture and the amount of biofuel you'd be producing. Now, on that note, combustion, whether it be from your car engine or from your heating oil-fired furnace, the 5 gases that make up combustion are carbon monoxide, carbon dioxide, oxygen, nitrous oxide, and hydrocarbon chains. These hydrocarbon chains are the big one, along with carbon monoxide, carbon dioxide. But even larger than that is water vapor, and that's what helps bind all of this together and causes so much of our environmental problem. So by being able to pull this through, all those, the carbon monoxide, carbon dioxide, hydrocarbon chains, and you're able to pull this through and do something with it, not just carbon capture. I read about this carbon capture where they're capturing the carbon monoxide and carbon dioxide, and they're just putting it in the ground and go, well, it'll be there in a million years. We can actually do something. We can produce a product. We can make a full circular, recycle, regenerative economy out of this, where not only is it something that could be self-sustaining, in other words, the biodiesel that's produced by it is utilized in the production of these units, but once the market becomes saturated, now we're not going to see the end of internal combustion engines for quite a while, but we can do something with the pollution. We can do something with the particulate emissions from the manufacture of concrete, the manufacture of various things, power plants, coal plants. We can do something with the pollution that's circulating all around us. We're breathing it in, whether we know it or not, and we can produce a viable, renewable green fuel source.
So now, are you going to have mobile units where you can suck in the exhaust from the carbon combustion engine directly and then make fuel that goes right back in the fuel tank? Or, are we looking at seeing something like that on your bus anytime soon? Or what's the next step for you there?
Okay, so that's funny you mentioned that. Many years ago, we had been running a small shop on a small 3-cylinder Shadura diesel. This diesel generator was so horrible that the exhaust stack would plug up. I mean, the inside of the stack would plug up, the whole top of the stack, it would just be this nasty tar substance. It would just build up and it would just slowly flow toward the ground. And there was a pond that we had there, and then we rubber lined it and what have you. And we thought, well, let's just take that pipe, run it down into the bottom of the pond. It has a bunch of holes in it. Just let the exhaust bubble. Maybe we can, stop a lot of this pollution. And it was summertime, and it was in Wasilla, Alaska. And with that generator running, now there's obviously the sunlight every day. It's an outdoor pond. There is wind. And of course, we are directly introducing straight diesel exhaust to this from a horribly producing generator. This engine was probably the worst of the worst polluters. And the algae that built up on that pond was so thick that we had to scree it off. Otherwise, it would stop bubbling where the generator couldn't push the bubbles through or couldn't push the exhaust through it. It would just build up like this lens. Then we had 55-gallon drums full of this basically biodiesel, algae diesel. We filtered the material off the top that, the plant leaves, sand, debris, silt. And then we just basically ran it through a press and just squished it and ran it back through the engine. Now, we didn't achieve a 1-to-1 ratio, otherwise that'd be perpetual motion, but we did offset a significant amount of the fuel that engine was burning.
So are you suggesting, like, as you know, we have these problems with, these bubbling, the ponds bubbling as the permafrost thaws and the methane and stuff is being released. So are you suggesting that this could be, the process could be similarly used, that instead of trying to spend a bunch of money to try to keep the permafrost from falling, that maybe what we should try to be doing is looking at how to build an effective skimmer to go out and collect the algae every couple of months and turn it into biodiesel rather?
Why not? And in fact, if you have a natural occurring source where it's constantly bubbling, that methane, carbon monoxide, carbon dioxide that's been trapped under the permafrost for millions of years, if you have these areas that have a large amount of it naturally off-gassing, why couldn't we put a couple of these out there and capture that, let the algae do its work, and then we have a biodiesel?
So basically at any point of exhaust or just in the air, we could put these things like along the highways and in near homes and stuff like that, and to just suck up the air that's there and then pump out clean air. So as you were mentioning before, this could be a mechanical replacement for some of the biological functions that we've lost in urbanization.
Correct. Putting it alongside of a highway, say in a more moderate climate, like down here in the lower 48, I could see doing that. I could see a small pipeline running alongside the highway to stations where they're collected and handled from there. You would have obviously the water. You'd have a little bit of electricity. Yeah, why not? I mean, if you've got congested highways where it's basically like a slow-moving parking lot of cars, that's a lot of pollution that could be captured.
Well, Chris, we're running up against the hour mark here, so I wanted to know, did you have anything else you wanted to share with folks, or anything you think they might want to know? I
offer these words of advice as an inventor: collaborate. You don't know who has some missing piece of the puzzle that you're working on, and you also don't know when you might have the piece that they're needing. But when we all start working together, that's when things start to happen, and that's where I'm at. That's where I'm pushing things like this forward to help art, to get the community involved, to get economic growth. And we don't need to have a stagnant economy. We can have a vibrant, renewable economy, and this is one of those potential avenues.
Amen, brother. And that's why ARC is happy to be here to support you and how we can. So do you want to share your contact information in case anybody wants to reach out to you, or?
Yes, my email address is alaskastar2000@hotmail.com. And my phone number is 907-775-0765. It's best if you text first, and let's get the ball rolling.
Okay. Well, Chris, thank you so much for taking the time to share with us today. This has been some really insightful stuff, and I hope the people at home get a chance to watch it and enjoy it too. But so this wraps up our 2023 Regenerative Planet Summit. Look forward to seeing you next year, where hopefully we can do all this stuff in person. So thank you once again. Stay beautiful and stay bold.
Thank you.